Hi children, this is your physical science facilitator SS from Commando Group of Schools. Welcome to the online classes. Children, in the last class we learned different equations of linear motions and some numericals also. Today, how to learn one activity based question. Okay, and just regarding to the lesson motion and some numericals and graphical questions also. Means this is the last class of the motion. Right. So let us see that activity question, the motion. So find the acceleration or velocity of an object in an inclined track. That is our aim. Okay, so is weight as that. Write an activity regarding the acceleration or velocity of an object which is in inclined track. The track is inclined like this, inclined, which is making some angle with respect to horizontal surface of the earth, and it is making some angle now. So that what we call inclined. So when the track is inclined, if the object is moving in the inclined track, then what about its acceleration and velocity? Okay, for that you have to do a small activity. So whatever the question is there, the question you have to change that as an aim. So what is the aim? To find the acceleration. A stands for acceleration, B stands for velocity of an object where in inclined track. For that purpose, what are the requirements? See here, one steel plate we need, and some books we need, and a track. Actually, track means it is a channel, just like you know what the track. When you track two tracks will be there, so like that you have to fold a channel, just like a wire. That wire has to be folded. The wire has to be folded. How? That the marble should not insert into it. Should not change. A track is there, the marble should move on the track. Just like one wire is like this, it has to bend, and like this you have to keep. Okay, so here it is folded like this. I will give the example. Just like it is a wire now. So just bend like this. Okay, so you bend like this, but the marble should not fall into it. It should be more than the size of the radius of the particular that one. Okay, so like that, how to make a track. If you made a track like this, now the track has to kept on the surface of some books, which is coinciding with steel plate, which is making an angle. Now the track is like this. Track is right. Okay, so for that, what are the requirement? Glass marble we need, books we need, digital clock we need, long plastic tube, this one, and steel plate. This is the steel plate, and about this long plastic tube or nothing but channel we have to use. Okay, but what about the procedure? First take a steel plate, on one edge arrange some books. Now keep the track on the surface of the book, which is making some angle on the other end of the steel plate. The other end of the steel plate, in one end we are using books, in other end this track is going to be adjusted. Now, what we have to do? Mark or graduated this track into equal divisions. Along of this one approximately 2 meters means 200 centimeter. Okay, so it means 2 meters, and it is to be divided into parts: 50 centimeter, 100 centimeter, 150 centimeter, 200 centimeter, like this. But take the glass marble, keep there about maybe 70 centimeter or maybe the 40 centimeters, like that. From there, you have to release the ball or marble. Then what happens? It will move towards the ground. Why? Because inclined position now, because of gravity it will move. Because of gravity it will move. Okay, so from there first you have to start with 40 centimeter. So you know the distance, you know the S value, distance value, what is about that? 40 centimeter. But don't forget the same time, at the same time when you are going to release the marble, we have to use the digital clock. Have to use the digital clock. Okay, at the same time, have to be used both. By using the digital clock, you have to go for that. Okay, and both at the same time, when you are going to release the marble, when you are going to release the marble at the same time, you have to start. And what time it is going to reach the ground, you have to calculate that. You have to calculate. So, for trial 1, maybe 4 seconds. For trial 2, maybe 3 seconds. For trial 1 again, maybe 4 seconds. You have to take the average time. Average time you have to be considered. Because if you take the first time, maybe some atmospheric thrust maybe, some all the cases, it may not be the unique nature of the atmosphere, or maybe changes. And you may not release it properly, or sometime may throw, sometime maybe some manual defaults will be there. To overcome that, you have to take trials, 3 trials, and you have to take average. Now distance you know, time you know, substitute here. This is about distance, meter per second square. Meter per second square means acceleration. You can find the acceleration. Okay. Now increase the distance. Increase the distance. Again you have to calculate. Maybe 100 centimeters or 100 centimeters. Maybe again have to use the stopwatch and gradually have to calculate. Distance is there, time is there. Again you have to calculate that one. All the values should be tabulated in this one. From this you can observe that it is moving with uniform acceleration. Uniform acceleration means gradually the velocity is increasing. Gradually the velocity is increasing, and the final column is going to be unique. Means when the body is moving in inclined position, gradually its velocity is increasing. Gradually velocity is increasing, but the body is moving with uniform acceleration. So what is your observation? From the above table, I observed that last column is same. Last column is same. Next, conclusion. From the above activity, I conclude that the object in the inclined position or inclined plane, gradually what is happening? Velocity is increasing and the object is moving with uniform acceleration. That is your conclusion. Okay, have understood? First, materials required, procedure and the table. When you are writing the procedure, then you have to represent the diagram also. Observation based on this table, the last column is observed that unique one. And conclusion from the above activity, I conclude that observation is very close to the conclusion. From the above activity, I conclude that acceleration is equal means when the object is moving in inclined position, gradually velocity is increasing and the body is moving with uniform acceleration. Have understood, children? It's about the activity, the motion. Okay, now how some of the graphical questions will come? Have understood? What are the requirements? Yes, straight plane, books, track. Next one, granulated, you have to granulate that one now. Keep uniform into equal divisions. Like that. Okay? So don't forget that I have to draw the procedure. Now, how can you say the nature of the object with respect to graphs? Okay. Commonly in the informative question, they are going to ask you like this. It's maybe a graph on x-axis and about y-axis. On x-axis, time, on y-axis, displacement. Okay? Maybe 1 second, 2 seconds, 3 seconds, 4, 5 seconds. Like this 1 meter, 2 meter, 3 meter, 4 meter, 5 meter. So it is in seconds and it is in meters. In this is read as different objects. Different objects like this, a body. A, it is an object, A. And there is another object, B. And one more object, C. So, all the bodies are start from rest. All the bodies are start from rest. Okay. Now the question may be asked like this: which object out of this ABC, which object is going with maximum speed? Okay, how can you say what is by speed or maybe velocity? What is velocity? Displacement by time. Displacement by time. Okay, so see here, displacement of the sea is approximately 1, 2, 3, 4, 5, 6, 7 meters. Maybe 7 meters, unlike this curve, 3 seconds. And when you see this one, it's about 1, 2, 3, 4, 5, 5 meters in 4 seconds. Similarly, this one, 2 meters and 5 seconds. So speed is nothing but the distance of the displacement from here. So which object has covered the maximum displacement here? C. Within a short span of the time. By comparing that, we can easily conclude that the object C is moving with the maximum speed out of these 3. Which is moving very slowly. A. What height is about B. So like that, graphical questions also we can answer. Okay, now? Now, in the numericals, they are going to ask different questions. Okay, so what is the ask like this? An object is vertically projected. An object is vertically projected. Okay, with an initial velocity of 19.6 meters per second. An object as projected vertically up with the initial velocity of 19.6 meter per second, and it attains the maximum height h max. Then it attains the maximum height. No, then find the maximum height. That is the question. So if you see the data first, data. When you see the diagram, you may see only one thing is given, only initial velocity like that. But so many things they have given. First you have to see that. What is that? Initial velocity. What is the initial velocity? U, how much? 19.6 meter per second. And the object reaches the maximum height. He said that it reaches the maximum height. When an object reaches the maximum height, then its velocity becomes 0. Yes or no? If I am going to project an object like this, when it reaches the maximum height, its velocity becomes 0. Otherwise, again it has to follow. When it reaches the maximum height, then its velocity becomes 0. Okay, so final velocity is 0. Don't forget, when it reaches the maximum height, then only the final velocity becomes 0. Final velocity, commonly represented with V, is about 0. And the object is moving vertically up. So acceleration is also given. Acceleration A, that is equal to minus G. What is the acceleration due to gravity? 9.8 meter per second square. It's about negative. Don't forget about that. And what is the requirement? Maximum height. H max equal to which displacement we need is question mark. So S is there, A is there, U is there, A, like this. These are the requirements. S, V, U, A. What is the formula we have? S is equal to, of course, V, U not, V square minus V square is equal to 2AS. Because what is the data we have? V is there, U is there, A is there, yes, we have to find. V, U, A, yes. What is the relation? V square minus V square is equal to 2AS. Then go for the solution. Okay, simply substitute the values here. V 0 square minus U 19.6 square is equal to 2 into A minus G into S is about h. Now, what I did here? Minus 19.6 into 19.6. Okay, don't multiply this. Keep like that only. This is what? Minus 2g is 9.8 into h. Minus get cancelled. Okay, now 19.6 into 19.6 is equal to, it is also 19.6 into h. Now, what is h value? H is equal to, get the 19.6 this side, 19.6 into 19.6 by 19.6, get cancelled. So, what is the h value? 19.6 meter. Don't forget the units. Okay. So, like this we can find the units. Okay. Right. Just pause the video and note it down. I will give one more problem to you. Okay. Hold on. Right. So, and one more problem is given like this in your textbook. The problem is there about a car travels from rest with a constant acceleration a for t seconds. What is the average speed of a car for its journey if car moves along in a straight line? Okay, so first what we said in the data, it begins with rest data. So initial velocity. Or initial velocity u is equal to 0 because it begins with rest. Next, what is the distance covered in t seconds? So time is also given. Time is t seconds and distance we have to find, and acceleration also given. Acceleration is there. Then what is the formula we have for this relation? What is the formula? S U A T. S U A T. What is that? S is equal to UT plus half AT square. Then go for the solution. What is the solution? S is S and U become as 0 into T plus half into A into T square. Now it becomes as S is equal to half AT square. What is the requirement now? What is the requirement? Find the average speed. Find the average speed. So average speed. What is speed equal to? Distance by time. We are having the distance here now. So average speed is S by T. So average velocity or speed is equal to, displacement is this one, half AT square whole divided by T. T and square get cancelled. Then average velocity is equal to A into T by 2. It will be the answer. Okay. If you believe or not, the same thing is given in the mains of the IIT also. Same thing. Very easy one. Okay, ma? So here it's about speed. Maybe considered as a velocity, then you will get displacement by time. So here, don't get confused. It is about speed. And here S stands for, this S stands for displacement. Don't get confused. Displacement. So here instead of average speed, I will write what? Average velocity. Then distance by or displacement by time, and therefore the displacement from this formula you will get this one. Okay? Right. Now we will see the gist about the chapter. That what we learned in this chapter. Okay, children? It's about the gist of our lesson motion. So, in this lesson motion, we learn about the relative terms, rest and etc. Means whether the motion and the rest are relative or not, and the different terms of distance, displacement, speed, velocity, acceleration, and their relative terms also. Average speed, average velocity, uniform acceleration, all those things we learn in this motion. And the equations of the linear motion, V is equal to U plus AT, S is equal to half AT square, V square minus A square is equal to TAS. Sn is equal to u plus n, u plus a into n minus half. These are the linear equations we learned, and different graphs with respect to time and speed or displacement with respect to time and velocity with respect to time and acceleration. So like that, so many graphs are also there. So children, here I would like to say one thing. Prepare your own gist like this, what you learn from this chapter. Okay, open the textbook and prepare a gist like this, then you can easily identify the concepts. Okay, where you are lagging behind and where you have to focus. Okay, so when you prepare by yourself, it will make interest on the subject, and it can be used. The memory phone also for a long span of the time it can be stored in your brain. Okay, it's about a small gist regarding to the motion. Okay, children. So it's about the chapter motion. Okay, I think you may learn well. You may understand very well, and practice with the help of the textbook and different reference books. So I am wishing you all the success. Bye.